Welcome to today's lesson on linear equations. In this video, we'll dive into the fundamental concepts of linear equations, exploring their definitions and how they translate into graphs. To begin with, let's break down the key components of linear equations.
A linear equation is an algebraic equation where each term has an exponent of 1, and when this equation is graphed, it always results in a straight line. This is the reason why it is named linear equation. Note that when an equation has an exponent of 2 or higher, as well as if the variable is inside the square root, it is not considered a linear equation. Linear equations can either be written in one variable or two variables. A linear equation in one variable is an equation in which there is only one variable present. It is of the form ax plus b is equal to 0, where a and b are any two real numbers and x is an unknown variable that has only one solution. A linear equation in two variables, however, is in the form of ax plus by plus c is equal to 0, in which a, b, c are real numbers, and x and y are the two variables, each with a degree of 1. Now, let us discuss these three major forms of linear equations in details. Standard form. As previously stated, linear equations can either be in one variable or two variables. The standard form of a linear equation in one variable is represented as ax plus b is equal to 0. These are examples of linear equations in one variable. Only one variable is present in the equations. The standard form of a linear equation in two variables is represented as ax plus by plus c is equal to 0. On the other hand, these are examples of linear equations in two variables, since the equations contain x and y variables. The second form of linear equations is called the slope-intercept form. The most common form of linear equations is the slope-intercept form, which is represented as y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. Y-intercept means that y has a value while x is equal to 0. And x and y are the coordinates of the x-axis and y-axis respectively. Since we have mentioned the slope of the line, the slope is equal to the ratio of the change in y-coordinates to the change in x-coordinates, or simply, we know this as the rise over run. Now, rewriting the linear equations in two variables into slope-intercept form is also possible. We only separate the y variable at one side of the equation and then evaluate the remaining expression on the other side. The last form of linear equations is the point-slope form. In this form of linear equation, a straight line equation is formed by considering the points in the xy plane, such that y minus y sub 1 is equal to m, the quantity x minus x sub 1, where x sub 1 and y sub 1 are the coordinates of the point and m is the slope. The slope-intercept form can also be rewritten to point-slope form, since we are already given a slope and the x and y values through the y-intercept. After determining the slope and the y-intercept, we simply substitute these values to the equation y minus y sub 1 is equal to m, the quantity x minus x sub 1. Then, we have now our point-slope form from our slope-intercept form that we have created previously.
Now, let us explore how linear equations translate into graphs.
Graphs have different looks and forms, but the grid's most common use is to create its image. It is made up of lines and points and is comprised of the following basic parts: the axis, the points and their coordinates, the four areas that the axis created called quadrants, and the plane where the axes are laid out, called the Cartesian plane. A Cartesian plane is a two-dimensional coordinate plane where two perpendicular lines intersect. These lines are called x and y axes. This horizontal line is called the x-axis, and this vertical line is the y-axis. The point of intersection of these axes is called the point of origin. This is designated with the coordinates 0, 0. The Cartesian plane is the space where points are plotted and the graphs are drawn or created. The Cartesian plane divides the coordinate plane into four areas called quadrants, where the axes are the border lines. It starts with the first quadrant at the top right, going counterclockwise. Each of these quadrants has specific assignments of the positive or negative signs of the number coordinates of points. Let us try to graph the forms of linear equations that we had previously. In graphing linear equations in one variable, we simply solve for the value of the variable. In this example, we get the value of y, which is equal to 1. To graph, we locate y is equal to 1 and draw a horizontal line since there is no value for x. Solving for this second example, we get the value of x. To graph, we locate x is equal to 3.5 and draw a vertical line since there is no value for y. To graph linear equations of two variables, we first assign values to the variables to make the equation true. Suppose we assign 10, 0 as the values for x and y. The equation becomes true. Therefore, it is a point in the line. And if we put 0, negative 10 as values for x and y, we verify that it is a point on the line. Since we have located 2 points, we can now create a line. In graphing linear equations in slope-intercept form, we first identify the slope, which is given by m, and the y-intercept, which is given by b. Since b is equal to 1.25, we start at y is equal to 1.25 since it is a y-intercept, and go down by 9 and go right by 4 to locate another point of the equation. By going down by 9 and right by 4 multiple times, we can locate points on the line. We then connect these points to create the line of the equation. Meanwhile, in graphing linear equations in point-slope form, we first identify the ordered pair x sub 1, y sub 1, and the slope given by m. Since the values for x and y is 0, negative 2, we locate this point and start from there. The slope is 1, so we have to go up by 1, and go right by 1 to locate the points of the equation. By joining these points, we get this line.
Now that we have learned about linear equations and its graphs, let us examine these examples.
Now let us examine these real-life examples involving linear equations, and let us try to provide what is being asked and graph the equation. Suppose you applied for a teaching job. Public school offers you a weekly pay of 4,500 pesos, while a private school offers you 100 per hour. Both institutions require for you to work 40 hours per week. which pays higher per hour. Let us assign x as the rate per hour of the public school. Therefore, we can now have the equation 4,500 is equal to 40x. And solving for the value of x, we now get 112.5. Therefore, the public school offers a better rate of pay at 112.50 pesos per hour than that of 100 pesos per hour at the private school. To graph this equation, we locate the value of x, which is 112.5, and then we draw a vertical line. This is now the graph of our equation. Examining the second example, if you want to budget 5,000 pesos for your birthday party, a pizza costs 400 pesos while the beverage costs 100 pesos. How many beverages can be bought if you decided to buy 4 pizzas? How about if you decide to rather have 6 pizzas? First, we let y be equal to the number of pizzas while x is equal to the number of beverages. Therefore, we can now have our equation, which is 100x plus 400y is equal to 5,000. Answering the first question and substituting the value for y, which is equal to 4 pizzas, we now found that the value for x is equal to 34. Therefore, if there are 4 pizzas, there will be 34 number of beverages. To answer the second question and substituting the value for y, which is equal to 6 pizzas, we identify that x is equal to 26. Therefore, if there are 6 pizzas, there will be 26 number of beverages. The ordered pairs for this equation are 34, 4, and 26, 6. By locating and connecting these points, we now create a line which is equal to our equation.
And there you have it. You've learned about the definition of terms in linear equations and how to graph them. Remember, linear equations are fundamental in mathematics and have a wide applications in various fields. Happy learning!
To evaluate whether you have learned from this video, let us examine and answer this problem.